Let's discuss question number 39 from test sets. This is from machine design. So the rope sieve of a balanced weight for a cage is supported on an axle of 250 mm length. Okay. The axle is supported on two bearings. So you have a bearings at the two ends and you have a rope sieve here. Okay. So at the cross section there are two loads. If you look at the loading, it is 15 and 15 kilonewton. Well, the resultant of this two is basically 30 kilonewton with no torque because it balances out, right? The moment here cancels at the center, so it's only 30 kilo. So 30 kilonewton of load is acting at the center, and let's call this as A, this as B. So dimensions are A is 90 mm and B is the total length 250 minus 90, that is nothing but 160 mm. Okay, so now it is like a shaft or a whatever you want to call a beam, the load at the center of 30 kilonewtons. Now in this case, so the reactions, there will be some reactions R1 and R2, and if you just draw the bending moment, you'll get to know that the maximum bending moment occurs at the point where the load is acting for an eccentric concentrated load. When you have an eccentric concentrated load on the simply supported bearing, the maximum bending moment comes here, and the value of the maximum bending moment is the load into the distances from the bearings AB, product of the distances by L. So this maximum bending moment comes out to be 30 kilonewtons into one weight is 90, the other weight is 160, by total length is 250. So this value, the maximum bending moment, comes close to 17.28 into 10 power 5 Newton mm. So this is the bending moment. Now once you know the maximum bending moment, obviously the stress will occur maximum there. So I have to use the bending equation. M by I is sigma by y. So sigma is my by I. M y is diameter by 2, I is pi by area moment of inertia of the cross section, which is circular pi by 4, it's 4 d power 4. So this is 32 m by pi d cube. Okay, so now I have to just substitute 32 into 17.28 into 10 power 5 Newton mm. Diameter is something which I need to find out, so d cube, and the normal stress maximum is given, the allowable is, so this sigma, if it is 65 MPa allowable, so what is the diameter? So that is the question. So from this I can find out diameter. So this comes closer to 65 mm. So diameter comes closer to 65 mm. So this is a fairly good problem. You have to just find out the bending moment, and then the section which supports the maximum bending moment is the section where you'll have maximum bending stress. So 65 mm is the diameter which is safe, the minimum diameter which is safe. Otherwise, if you have a diameter lesser than that, then the stress will go up and it will be more than 65 MPa. So the answer for this is C. Thank you.